Hi guys, Ashwin here. This is episode 9 of Sui Deep series, and it's going to be obviously a part 1 because Walrus is also a quite big protocol, native protocol on Sui, which is obviously created by Mist Labs. So it is a storage layer by them, created by them, and today we'll be discussing about what's Walrus and how it acts as a data availability layer for Sui, and also not only for exactly for Sui chain, it also acts as the DA for many applications built on Sui, right? So that is one thing, and how it is very specialized for unstructured data. Say this is something very quite interesting that I've recently seen, or when Walrus was launched. Okay, so DeepSeek, the open source model itself, the max billion parameter version, that exact LLM itself is stored on Walrus, and you can compute from that exact storage layer. That's something very interesting, right? The size of the max billion parameter version, right? So that is one thing, and how it exactly acts as a so for instance, if you store some data into Walrus, you can program the data whenever you want. So there are some quite good features in Walrus to be we'll be covering about them in this video. And also they use red stuff encoding algorithm under the hood. So what is it exactly? And it's just an overview because we can't go into the depth. It involves lot of cryptographic things that we need to understand. And later on we will be understanding the whole architecture of how Walrus and Sui together works, so that it acts as a storage layer, and Sui acts as a coordination layer for it, and types of calls that we make from the Walrus Publisher. So we'll discuss what is Walrus Publisher and stuffs. Yeah, let's get started. So first of all, we want to start discussing what is Walrus, right? So Walrus is nothing but a decentralized storage system. So we obviously know about IPFS in EVM side. So how it exactly differs from IPFS, and we obviously need a storage layer in Web 2 or Web 3 ecosystems. Like if we think about Web 2, we just use PostgreSQL or any SQL DBs, and when we think about having some immutable data getting stored, immutable getting stored data for with a particular retention period or something like that, and programmable data when we talk about Walrus. So when we think about in that kind of way in Web3 point of view, and also having some consensus happening for whatever data that you're storing in. So we'll talk about it in this video itself. So yeah, that is how the storage layer works, right? The decentralized storage layer works. So Walrus exactly does that. So yeah, let's get to it how it works exactly. So think of you are building this application, something a DApp on Sui. Okay, you need obviously a storage layer, right? So why you needed to just write some data and also retrieve some data. So just the normal stuff that we are discussing right now. So let's say how exactly Walrus differs from this exact thing. Let's say I have huge data, say something like 120 GB of data. Okay, so assume you are going to store this exact 120 GB of data into let's say AWS. Okay, you are going to write the data and you are going to read the data just quite a while. Like you also want to read the data for quite instance, right? So you just estimate the cost of how it's going to happen, right? So how it's going to occur, it's just going to be an enormous amount. So you are going to reduce it totally by a half, or even below half when we use Walrus. So how it exactly is going to do is we will discuss that as well. This is one of the benefit that we talk about when we use Walrus. This is one thing, and another thing is So another thing is, let's say you have something like an LLM, whole DeepSeek LLM, the max billion parameter version. Okay, so assume I want to store this entire LLM into a storage layer. It's going to be Walrus, right? So this is something already happened in Walrus in Sui ecosystem. They some protocol just store the entire billion parameter of open source DeepSeek LLM into the Walrus storage layer, and they use that to use that for computation. Computation in the sense like have an AI agents make some calls to LLM model, this is exact DeepSeek model, and have some computation on their applications. So this is such thing like it's why I'm mentioning this is it's something like an unorganized or unorganized data, right? So let's take up something like it's not something like a structured data when we talk about. So it's not something like just the JSON metadata that you are storing inside, right? It's something like totally an unstructured data that you just store into Walrus and use that for computation. So that is something quite interesting, and this is something. And let's just yeah, next we also want to discuss about what is programmable data in Walrus. So next up, we'll also see what is programmable data. So let's say I'm storing. This is something like um, it's much relevant to Seal as well. I'll take up an example with Seal because it will be very very useful in the next video that we'll be discussing. Let's say I want to store some data, and this exact data in Walrus is open source. Sorry, not open source. Like it is something everyone can access it. Everyone can see it. So entire globe itself has the read access to the Walrus, blobs, whatever blobs that you're writing into Walrus. Every entire ecosystem itself can see to it just with the blob ID. Okay. So what is blob? Blob is nothing but whatever data that you store in. It's called as blob in Walrus, and with just the blob ID, you can just from the CLI or from any TSSDK, you can just make a call to the Walrus, Walrus ecosystem and Walrus network, and you just retrieve the data and you can read it. So it's simply like that. So what say I want to program this data using Seal. So Seal is nothing but access control layer. You can keep it in this way, but we will explore in deep fashion in the next episode. So you use Seal to basically encrypt the data and then store the data into Walrus. So after you encrypt the data, you store the data into Walrus, then you make sure that you make a call, say decrypt the data from making sure that you call some key servers and get the key for the decryption, and via a smart contract you are going to decrypt the this exact data that is stored in Walrus, and then you can see it. So why we need this kind of programmability in this exact storage mechanism. So programmability comes via the smart contract, move smart contracts that we will be designing for this exact process. So it is something like, say I am going to post some data and it's something sensitive from the user end. It shouldn't be revealed to the ecosystem, right? So you can encrypt the data and you just give the access to only the user end. So you can do that via this programmability that we are talking about. So this is one such example that I want to give. Then next up we will be discussing about what is red stuff encoding algorithm and what is the architecture of Walrus. So yeah, let's get into it. So let's start discussing the architecture of Walrus. So Walrus mainly contains publisher, Walrus publisher, and aggregator, Walrus aggregator. So what is the purpose of aggregator and publisher? I'll just define it here itself. So aggregator, mainly you use aggregator to read the data from the Walrus storage nodes. Okay, so aggregator's purpose is that. And what is publisher? So publisher's purpose is to whatever data that you put into publisher, you use some encoding algorithm, something like a red stuff encoding algorithm under the hood, that is something like designed by Mist and Labs, that exact binary file. You make a call to that exact binary file, which is the Walrus publisher, and that publisher is going to make sure that it encodes the data and starts to construct the slivers. So 1 2 3 4, something like if you send 3 byte data, it just makes sure that 64 MB of encoded slivers comes out of the binary, and it's not yet coming out of the binary. We will explain the flow itself now. So let's say this is the publisher that we are talking about. So I'm going to just make sure that I'm putting a data, or just making a store call to this exact publisher. So what exactly is going to happen is, under the hood, this exact publisher makes sure that it uses an encoding algorithm to make sure that you encode the data, right? So let's say I am having a 3 byte. I have a So let's say I have a 3 byte data. It's going to be coming up until something like 64 MB of encoded data. So why exactly we encode this data? We will just talk about that as well. So next up, you get this encoded data, right? So I'll explain the whole architecture itself. So this encoded data is just inside this binary right now. What exactly happens within seconds is, you make a call to Sui smart contracts, or just you can assume something like Sui chain for now. So what it says is, this exact address internally, this publisher is mapped to a Sui CLI as well, so another some binary. Okay, so this exact CLI is mapped with an address. Okay, so what exactly it says is, this publisher says this exact address is going to store this amount of encoded data into the storage nodes. So it requires some space in storage nodes, so he is buying some space, or he is reserving some space via the contract that it is existing in the Sui Sui chain. Okay, so this is the exact flow. So it makes a call to the smart contract, and spends some val token. So val token and some Sui coin. So val is also a coin actually. So val is val coin and Sui coin. So Sui coin is for the gas, and val coin is for the storage reservation that you are doing. And it's something like you have some metadata stored in the Sui chain, saying that this is the exact storage amount of storage that you are going to get, and the epoch that you are making this exact storage, storing time. So epoch is nothing but, assume you have your own time system in the chain, and with the time system you define some rules within your chain, saying within this epoch I'm going to make sure that these takers going to get the reward, something like that. So epoch is something Sui ecosystem uses. Okay, so that is epoch, and within this epoch, this exact file is going to get deleted. So you have something like deletability as well. We will talk about that as well. So okay, so this is the exact process of reserving space Then later on what happens is, after reserving space, you make a call to the publisher itself, and then that publisher, what it does is, it's going to say to the storage nodes, Walrus storage nodes, say I'm going to store some data into Walrus storage nodes. So you have reserved some space, and there are multiple nodes in the storage nodes in the network, and you are going to you have already constructed the slivers, something like, if it is a 3 byte 3 byte data, you have some 200 or 300 slivers. So you have some 200 or 300 slivers. These exact slivers are distributed to the storage nodes. Okay, and yeah, this is what happens. You are storing the encoded data into the Walrus, and later on what happens is, then later you get certifications outside from these storage nodes, saying that this exact certification is nothing but from the storage node, saying that this encoded data is stored into the storage node itself. So from each node you get the certification, not exactly each node, 2 by 3 quorum. So 2 by 3 quorum voting, something like the consensus. Okay, I am talking about the consensus exactly. So 2 by 3 of the storage nodes will say, I have from them you construct certification. Okay, so then from there on, this exact certification is gathered by this publisher itself. Okay, not something like by someone. From publisher only you do that as well. Then later on, this exact certification is also stored on chain. Okay, and this is something a metadata. So it might be a messy architecture, but you can get the point, right? So that's what I'm coming to tell now. So this is the exact whole architecture, and you just store the certification and you pay some Sui gas fee. So some pro tips is, you always try to avoid making calls to the Sui layer, that is the coordination layer, right? So avoid making calls, in the sense, you don't need to have some 3 bytes of data getting stored quite often, and you spend lots of gas fee on Sui, which is not applicable, right? So that is what I'm coming to tell. You just have some bundling up mechanism, and you bundle up those data, and then put into Walrus, and you reserve have the certifications stored on chain. So that's something, a pro tip I just want to give. So this is the architecture that I want to give. So why here red stuff encoding algorithm? We'll discuss that. So red stuff makes sure that say 3 bytes of data, I am converting it as 64 MB encoded data. So this exact say I'm just going to retrieve the data from the Walrus storage nodes, something like there are 5 storage nodes, for instance. Okay, so if I make call to just, but the whole 64 MB encoded data is stored in the 5 storage nodes. Okay, but I'm going to make a call to just 2 storage nodes and get you the 3 bytes of data that you stored. How? So this is the magic that red stuff encoding algorithm does. So it basically encodes the data and puts into multiple storage nodes, but the replication factor is quite minimal, that you just get you just involve some very few storage nodes, and get the entire data itself. That's where this red stuff encoding algorithm plays a star role, but that is one thing, and it is also quite fast as well. So here, how, what is the part of aggregator? So aggregator basically it's something like another instance that you can set up, and it's going to be a binary file given by the Mistral Labs team, and you're just going to make calls to this exact storage layer, storage nodes, and it's in the form of encoded slivers, right? You just get the data to the binary back uh, as encoded sliver format, and this binary makes some have some logic, and it returns you the original data that you stored. So whatever data, PNG or JPEG, whatever kind of format that you are storing, right? So it's going to accept whatever you put in. So this is the architects that I wanted to talk about, and now let's get into types of calls that you can make, and what is deletable blob. Let's get started with that then. So type of calls that you will be making via the publisher. It's going to be simple, so it's something like store and read, then later on delete for now. Okay, so there might be something quite good as well, but this is the primary functions that we'll be using, primary calls that we'll be doing via the publisher. So store basically stores the blob, and read basically reads the blob, and delete, this is going to be something different. Delete, it's obviously going to delete the blob, that is quite understandable. Say I'm going to store the blob for one epoch, something like one epoch, in the sense it might be 2 days. It's based on the environment that we are going to post in. So if it is a testnet, it's going to be something like 1 day or 2 day, and if it's going to be a mainnet, it's going to be something like 2 weeks, I guess, in Sui mainnet. Okay, Sui mainnet or Walrus mainnet. So let's say I'm posting it for 2 days, and after 2 days it's going to get obviously deleted. You can't read data later on after it's deleted, after the 2 epoch. So what I'm going to do is, there are two kinds of blobs that you can store. One is deletable blob, and another one is you just mention it as false, in the sense it is not deletable blob. Okay, so if it is not a deletable blob, you are obviously going to lose it someday. Any blob, you are going to obviously lose it. It's just based on your retention period, right? So okay, so what is the exact difference between deletable blob and not deletable blob, non-deletable blob? Okay, so you can also make sure that this, another one thing I should mention is, you can use valcoin to extend the epochs, that is like extend the lifetime of the blob that you're storing in. Okay, that is one thing I want to mention, and difference between deletable blob and not deletable blob we'll talk about now. So let's say I'm storing 3 bytes of data now, something same 3 byte, and to the Walrus Walrus storage node, storage layer. Okay, so it's a deletable blob. Okay, so what I'm going to do is, after quite some time, after 1 or 2 days, I'm just angry, and what I'm going to do is, I'm going to delete this blob now. So make a delete call to this exact blob that we're storing using the blob ID, and now I'm deleting the blob, right? So what happens is, the space that you reserved for this exact purpose, the reserve space call that you did, what you are going to do later on is, say from the same address, you are making another call to store some other data into Walrus. You can use the same reserved space from the ecosystem, that is from the storage layer, that is from the storage nodes, and you make sure that you reduce your amount of fees or fees involved for the purchase of, for the reservation, right? For the reservation of storage nodes, you reduce the val involved. So you reduce the val involved for purchasing, for reserving the storage nodes for your storing of data. So this is something quite beneficial, right? It's very beneficial actually. So that is one thing. And what if it is not a deletable blob? Then yeah, that's it. You can't make sure that you reduce the fee involved, right? So this is the disadvantage that I want to talk about. So this is one thing. And next up, yeah, let's talk about setting up our own publisher and aggregator, and how the architecture would look when you make a call to your servers. So yeah, let's jump into the escalator. So let's say I am going to set up my own publisher and aggregator. Okay, how we are going to set up your own publisher and aggregator? It's quite simple actually. You install the Sui CLI. I have just posted it as a blog. Okay, I will ping them in the description. And Sui CLI, and you install the Walrus binary, and you just configure both of them together. And later on, you make sure that you are going to use this exact Walrus binary, acting as your publisher. From, I'm talking about something like locally now, locally, or if you configure the same thing in any instance that you're buying, it's going to be the same process that we are discussing. Okay, publisher and aggregator, you configure both to the same port, something like 9092. Okay, so you just configure it to the 9092 port. It's going to be a publisher and aggregator configured in one single port. So okay, so this is something like you have started your daemon. It's a daemon service you are starting in the instance. And what you can do is you can build your application to make sure that you make some calls to this exact publisher. This is your Walrus publisher and aggregator, and you use this Walrus publisher and aggregator as a middleman configured to your address, and you make some calls via this exact publisher to store the encoded data, make calls to the Sui chain. So yeah, this is the whole, it acts as your middleman, right? So, and also you use the same port to also make sure that you read the data, so from the exact storage node that we are talking about. So why we want to have it as a same port? You can have it as a different instances as well, that is up to you. It's based on your use case. Let's say you want an aggregator separately, and you make quite a lot of reads, then you want a separate aggregator, and you have a separate publisher for when you have an intense task or intense data putting into the Walrus ecosystem. So yeah, this is all about Walrus, and let's get into something like to my terminal, and just explore some of the commands that is in Walrus CLI, and from my own local publisher and aggregator, of how we are going to store data and retrieve the data out. Yeah, let's jump into it. Yeah, so I have already configured my Walrus and Sui together. So okay, so I am just showing it, and I will attach my blog under the description so that you can just easily set it up. So what I'm going to do is something like cache1.txt. I'm just going to create a file, broskis, something like that, and I'm just saving it. As you can see, I'm just going to make sure that I'm going to make a command, say I'm going to store this exact file into storage nodes, that is Walrus storage layer. So how I'm going to do this is, as we have discussed, my exact local system is going to act as a publisher now. So and also I have configured it to be an aggregator as well. So you'll see what is it. So what I'm going to do is, I'm just mentioning the file name and epochs one. Okay, and what I'm going to do is, I'm going to say I'm going to store this exact file for one epoch, which is going to be something like 1 or 2 days in testnet, I guess. So it differs from the from the environment. It might be differing based on what environment that you're posting in. If it is a mainnet, 2 weeks, or if it is a devnet, it's going to be 1 week. So if it is a mainnet, it's going to be 2 week, and testnet or devnet, it's going to be quite less. So what I'm doing is, I'm just going to initiate it, and whatever process that we discussed in the architecture, it's going to happen. Yeah, storing one slivers with metadata. You can check them via your local machine as well. So whatever that we are doing right now. So as you can see here, it is a deletable blob. So I want to mention something like flag hyphen deletable deletable, so that it is a deletable blob. So that is a difference that I want to point it out here. So encoding type, red stuff for read Solomon, expiry epoch 167, cost of the val involved, and unencoded size is 12 bytes. It's a 12-byte file, and as you can see, the encoded size is 63 MB. And blob ID, Sui object ID, and total encoded size, total cost involved. These are the things. So let's just this is one thing, right? So let's say I want to read this file, walrus read, and I'm going to use this blob ID to just read the file now. So now my local system acts as an aggregator to read the file. So slivers receive, and where it is, eyebrows keys. So this is how the Walrus storage layer works. And let me jump into my browser now. So I'm just going into the Suiscan testnet to just show you the exact object ID that is stored. And yeah, this is something I want to mention. So whatever blob is you are storing, it is of type NFT in Sui, and as you can see here, owner address, it's my address because I'm making the call, configured to my Sui CLI and configured to my address, and this is the object ID. And as you can see, two exact transactions took place. So first transaction is reserve space, and in the reserve space we are obviously going to spend some val, and P for gas fee, and val is for purchasing the reserving the storage nodes. As you can see, the storage nodes, and the created object created object, and then created NFT type object, and it's of type blob. And yeah, that is one thing. And let's see about certify blob. Yeah, it's going to be something like what blob you have stored, the blob that you have stored, and what is the exact storage space that you have covered for that exact blob. Those are the metadata that you are storing here. And as you can see, only the gas fee is spent over here. So yeah, this is all I wanted to cover in this exact video. We obviously might have a part 2 for Walrus, and there is a continuation that we wanted to do for Sui indexer as well in the part 2. Part 2 is pending for Sui indexer because yeah, Sui Foundry is coming up, and I'll probably build a Sui indexer over there, and I just wanted to discuss about that Sui indexer straight ahead instead of building a separate indexer for any other purpose. Yeah, let's catch up in the next video. Thank you.